Hello students, welcome back to the fourth video of this playlist. So in this video we will be solving question number 4 from P4 January 2024 paper. So let's see the question number 4. Basically question number 4 is from differentiation topic of your P4 syllabus. To be more specific, it's rates of change part of differentiation topic. So basically the concepts behind this question will be from chapter number 5 of your P4 book, that is differentiation. So let's get started with question number 4. So right at first you can see figure number 2 on the screen. So basically there is a cone. A figure of a cone is given with slant height L, its vertical height 5 centimeters, and its base radius is R centimeter. Okay, so let's see what they says here. A cone shown in figure 2 has fixed height 5 centimeter. Okay, base radius R centimeter, slant height L centimeter. Now part A, they are asking to find an expression for L in terms of R. We need to find an expression for the slant height L of this cone in terms of what? Base radius R. Okay, so this is simple for 1 mark. You see, it's for 1 mark. So basically if you see the shape of the cone, basically the slant height L, the vertical height 5 centimeter, and the radius, base radius R, it is making a right angled triangle. So definitely for a right angled triangle we know the most renowned theorem, that is the Pythagoras theorem, right? So we will directly use the Pythagoras theorem to find out a relationship between the slant height L and the base radius. So let's see. For part A, using Pythagoras theorem we can write what? We can write L squared equals to what? 5 squared plus what? 5 squared plus R squared, because the Pythagoras theorem says that what does the Pythagoras theorem says? It says that the square of the hypotenuse, that is the slant height squared, will be equal to the square of the sum of the squares of the other two sides. So other two sides are 5 squared and what? R squared, provided that the triangle has to be right angled triangle. So we need an expression for L. So make L subject. You will get square root of what? R squared plus 25. That's it for 1 mark. Okay, let's move on to part B. What they have asked in part B: given that the base radius is increasing, it's increasing, okay, at a constant rate of 3 centimeter per minute. The base radius is increasing. Okay, the rate of increase of base radius is given. That means this is which rate of change equation? dr over what? dt, right? It's dr over dt. Okay, so dr over dt equals to what? dr over dt, it is equals to 3 centimeter per minute, right? It's 3 centimeter per minute. Okay, so we know this rate of change value. Fine. So now the question is asking, find the rate at which the total surface area, find the rate at which the total surface area of the cone is changing. So rate of change of total surface area is given by what? S. It is represented by S, right? They have given there. This is represented by S. So rate of change of total surface area, that is what? ds over dt, right? We need to find out ds over dt when the cone is when the radius of the cone is what? 1.5 centimeter. That means when r equals to 1.5 centimeter, we need to find out the value for ds/dt. So for this type of question, this type of questions are very frequent in the past papers, like questions from rates of change. So for this type of questions, the concept is that we have to represent the rate of change equation in terms of the known rate of change equations. Make sense? We have to represent the rate of change equation. What's the rate of change equation here? ds/dt. So we will represent ds/dt in terms of the known rate of change equations. So figure out what are the known rate of change equations here. Write it first. We know dr/dt, right? We know dr/dt. This is a rate of change equation, isn't it? So let's represent it in terms of what? dr/dt. So ds/dt can be written as what? dr/dt, right? So look at the denominator of the left hand side and the right hand side. They matched, but only the numerator are not matching. So in that case, we have to eliminate dr in order to what? Match with the left hand side, isn't it? So let's multiply the right side by what we can multiply. Okay, now what we should multiply here? We have to represent ds/dt in terms of the known rate of change equations, right? So look, another rate of change equation we can figure out. It's from this formula. This hint has been given by the question. The s is what? Pi r squared plus what? Pi rl, right? So look, s equals to pi r squared plus what? Pi r l, right? So in place of l, you can put the equation for l just we found in the previous question. So that should be what? Pi r square root of what? 25 plus r squared. Fine. Now just what we can write here? Pi r squared plus, take this r within the square root. So what we will get? Square root of 25 r squared, because square root of r squared. Square root of r squared, it is same as r, right? So if two square roots are in multiplication, we can make them multiplied as a whole, right? So 25 r squared plus what? R to the power 4. So we got an equation for the surface area in terms of r only. Now we can differentiate it. What we will get? ds/dr. Why am I differentiating this? Because we need to represent ds/dt in terms of the known rates of change equation, right? So we can put it there, ds/dr, right? So look, dr diagonally, dr cancels out, so ds/dt will be remaining. Left hand side equal to right hand side, isn't it? Okay, so let's differentiate. 2 pi r plus, it is basically a composite function, so we need to differentiate it using chain rule. So if we write its power, it's better to represent it with its power. Power is what? Half, right? It's better to show its power. We can write there pi r squared plus pi times what? 25 r squared plus r to the power 4 to the power whole half, right? Fine. Now just differentiate. Half of pi, the power will get multiplied with the coefficient, and then differentiate the part within the bracket. What you will get? 50r plus what? 4r cube, right? 4r cube. Okay, and then we need to subtract 1 from the what power, right? So 25 r squared plus r to the power 4 inverse half. It will be inverse half, because half minus 1 is what? Negative half. That's it. So we got the equation for ds over dr. Now let us simplify it. 2 pi r plus what? Half of pi. So basically if you multiply half of pi, you will get pi times what? 25r plus 2r cube. It will be 2r cube over what? Square root of inverse half is what? It will be on the denominator with the square root. 25 r square plus r to the power 4. That's it. We got the equation for ds over dr. We are right at the end. So now our work is to just put the value of r. The value of r is what? The value of r is 1.5. So let's put r equals to what? 1.5 there. Then what you will get? ds over dr. So that would be what? This value. Use your calculator to find out the value. So at first let us find out the value for the fraction. 25 times 1.5 plus 2 times 1.5 cube. Okay, exactly 2 times 1.5 cube times 3.1416, that is pi over square root of 25 square root of bracket 25 times 1.5 squared plus 1.5 to the power 4. Fine. So what you will get? The value of the fraction is 17.75 something. Okay. Next is we need to figure out the value for what? 2 pi r. So with the value of this fraction, we have to add 2 pi r. 2 times 3.1416 times 1.5. So we get 27.17 something. Okay, 27.17 something. So we need the value for ds over dt, right? So ds over dt is what? Just we saw the equation dr over dt, which is 3, right? Isn't it 3? Yeah, it's 3. So 3 times the value what we found just earlier. Okay, so 3 times 27 point what? 17 something. So times 3. We are multiplying the answer on your calculator by 3. So we get 81 point what? 5. How many decimal places or significant figures they wanted? 1 decimal place. So this is 81.5. What would be the unit? Centimeter squared per minute. Fine. And this is basically the value for the rate of change of the what? Surface area of the cone. And that's all about question number 4. That's it.